Hello guys, we are meeting once again. This is a question for last block, power machines N5. So it's question 1 and it carries 20 marks. Now it's a very easy topic once you understand what you're supposed to be doing. So I'll read question 1 says, a certain gas occupies a volume of 0.45 meter cubed. Here they just made a mistake. It was supposed to be a meter cubed because volume is measured in meter cubed at a pressure of 170 kilopascal and a temperature of 21 degrees Celsius. And is adiabatically compressed to 1380 kilopascal. The density of the gas at STP is 1.362 kgs per cubic meters. And our CV is given as 716 joules per kg Kelvin. So one most important thing which we need to understand, we can summarize the data that we are given. So let's check what are we given there. Let's take down our data. I see we have our V1, which is our volume, 0.453 cubic meters. And then our P1 is 170 kilopascal. Our T1 is given as 21 degrees Celsius. We add plus 273, which gives us 21 plus 273, it gives us 294 Kelvin. What else are we given? A P2, it is compressed to a P2 of 1380 kilopascal. And then our density is given as 1.362 kgs per meter cubed. Remember, it's at standard temperature and pressure conditions. And our CV is given as 716 joules per kg Kelvin. So if we divide by 1,000, it gives us 0.716 kilojoules per kg Kelvin. Now, this is a very simple question, but many people leave the exam room thinking like they got it right, yet they did the opposite. Now, you need to understand that your normal conditions, when do you use these conditions? And when and how are you supposed to use your conditions at STP? Now, and there's an emphasis again, the process is what? An adiabatic process. Now, of importance, now if you check adiabatic process, it is a process which is conducted in such a manner that our heat transfer is equal to 0. In other words, it is conducted in such a manner that there's no transfer of energy into the system or out of the system. In other words, it's typically the opposite of the polytropic process. Okay, let's go to the question. On 1.1, they want us to calculate the value of the gas constant. So P1, V1 equals to MRT1. So they do this, or they give such a question like this deliberately. They know that many people, they will get it right. But some who are not going to be fine again, they might not get it right. So be very careful when you have a question like this that operates under STP or NTP conditions. Now, our P1 at STP, remember this is our standard temperature and pressure. Our pressure at STP is 101.325 kilopascal. And then our V1 at this density, at STP, our V1 becomes 1 meter cubed. Remember, if you look at our density, it is given as what? 1.362 kgs per meter cubed. That per meter cube means that at these conditions, STP conditions, our V1 becomes 1 meter cube. And then our mass, it becomes the given density, 1.362. We are looking for gas constant. Our T1 at STP, T1 at STP is 0 degrees Celsius, 8 plus 273, so it becomes 273. Be very careful on this part. So this becomes 273. Now many candidates, they do make a mistake, or a number of mistakes rather, on these 2 points here, mass as well as what? Temperature. You might find a scenario where you were given a different mass, and then they will come and substitute that mass here. That's the end of you. Some they will come and substitute 294 here. That is the end of the what? Of the story, because we calculate the gas constant of air at STP conditions, not at normal conditions. But the gas constant that you are going to get at STP, it remains the same for other conditions. Therefore, we can substitute here. Let's get our gas constant, which is our R. So we have 101.325 times 1 over 1.362 times 273. I'm getting something like 0.2725 kilojoules per kg Kelvin. Let us observe if we have substituted everything correctly. Our P1, yes, then our V1, our mass, our gas constant, and then our T1. So that's what we are supposed to get as our gas constant, which is correct. And then we can go to the second part. They want the value of our CP. So we know we can use our formula R equals to CP minus our CV. Already we have our gas constant, which is 0.2725 equals to CP minus, what's our CV? 0.716. So what becomes our CP? So it becomes 0.2725 plus 0.716. So if we add this and this, we get 0.988 which is normally kilojoules per kg Kelvin. But normally we know that it's supposed to be 1 point something, but because of the data that we are given, it's closer to 1. And then on 1.3, the question says, find the value of gamma. That's our 1.3. But gamma equals to CP over CV. In other words, our adiabatic gamma, it is basically the ratio of our CP divided by our CV. Our specific heat capacity at constant pressure and our specific heat capacity at constant volume. The ratio of the two gives you the value of our gamma. CP 0.9885, which is the one which you got from here. And then our CV, it was given, which is 0.716. So let's divide the two to see what are we getting. 0.985 divided by 0.716. I'm getting 1.38 as the value of my gamma. And then let's go to question 1.4. Calculate the final absolute temperature. So they want us to calculate our final absolute temperature. So we can use many formulas. Once again here, we can use P2, V2 equals to MRT2. You can as well use T2 over T1 equals to, which other one can we use here? P2 over P1 to the exponent of gamma minus 1 over our gamma. We can also use the other one, which is T2, which is similar to this. T1 equals to V1 over our V2 to the exponent of gamma minus 1. So, because remember you'll be writing this under exam conditions, so try to pick a formula that will not waste your time. If you check on this one, a number of things are not there, so it may take you a bit of time to calculate those missing values. And then if you look at this one, T2, and then it becomes fine because already we have our P2, we have our P1, and then we have our gamma. The problem with the first one, we don't have our V2 as well as we don't have our T2. So it will take a bit of time for you to put those things in order. If we look at this one, we have all our volumes. We only have V1, we don't have our V2. So we don't have V2 as well as our T2. So it will waste your time again to get those two. So this one becomes an easier formula to use. So we can, from this formula, we can now say T2 equals to T1 into P2 over P1 to the exponent of gamma minus 1 over our gamma. Our T1, we use our T1 at normal conditions, not at HTP. So T1 is 294. Our P2 is 1380 over our P1 at normal conditions, it's 170 to the exponent of 0.38 over 1.38. So let's get our final absolute temperature. 294 times 1380 over 170 to the exponent of 0.38 over 1.38. So I'm getting something like 523.323 Kelvin. And finally, we are supposed to calculate our change of internal energy. So change internal energy, that's our delta U equals to MCV into T2 minus our T1. So we have, we don't have our mass. So what we need to do now is to calculate our mass. But when you calculate our mass, let us calculate at this point, which is P1 V1 equals to MRT1. So be very careful again when you're looking for your mass. We don't calculate our mass at STP. We calculate our mass at normal conditions. So at normal conditions, our P1 is 170. Our V1, at normal conditions, what's our V1? It was given as the one that you said it was an error, which is 0.453 equals to M. Gas constant, we got 0.2725. And then our T1 at normal conditions, 294. So from there, we make our M, or our mass, the subject of the formula. We get 170 times 0.453 divided by 0.2725 times 294 times 294. What are we getting here? 294. I'm getting something like 0.9. Let me just verify whether I punched correctly. So we have 170 times 0.453 divided by 0.2725 times 294. So it's right, we're getting 0.96124 kgs. Now we come here, we substitute our mass. which is 0.96124 times our CV, 0.716, our T2, our final temperature, we got 523.323 minus our T1 at normal conditions, which is 294. Let's get our answer. 0.96124 times bracket, rather times 0.716 times, or rather into 523.323 minus 294. I'm getting 157.83 kilojoules. So basically this is how we are supposed to solve a problem like this. It's a very simple question, but remember how you get your gas constant. We calculate our gas constant using the mass. It will be the given density, and our T1, it will be at STP or at NTP if they decide to give you under normal temperature and the pressure conditions. So thank you so much. Please don't forget to follow our page on Facebook. It's Engineering Hub. So please follow our page. We do post a number of positive questions and answers, as well as some videos. Very soon, maybe in a space of days, we are going also to be uploading a number of videos on our YouTube channel. Thank you so much. See you on the next session.